detection software, please stand by. Hello, it's your friendly neighborhood RoboNeighbor, also known as Jarvis. How may I assist you today?
Yo, what's up, bro? You working on your homework?
Yeah, I'm having trouble answering what a quantum computer actually does differently from a normal computer.
Yeah, that's a tricky one. I think it has something to do with having more options in a binary system. I'm not completely sure, to be honest.
You should call our AI assistant RoboNeighbor. He should be able to help.
That sounds like a great idea. Hey Jarvis?
Activating facial detection software, please stand by. Hello, it's your friendly neighborhood RoboNeighbor, also known as Jarvis. How may I assist you today?
Whoa, that's cool. It follows where my face is. What does a quantum computer actually do differently from a normal computer? Be really specific, Jarvis.
Quantum computers use quantum bits, qubits, instead of traditional bits, allowing them to perform complex calculations much faster than classical computers. They can process multiple possibilities simultaneously, making them ideal for solving certain types of problems that are difficult for classical computers.
Wow, thanks, Jarvis.
You're welcome. If you need anything else, feel free to ask.
RoboNeighbor is a companion robot that connects people through live two-way audio and engages them with a fun and expressive AI assistant. It can communicate with anyone on the same network, making it a social tool for staying connected at home. Beyond simple conversation, RoboNeighbor combines real-time interaction with advanced AI, allowing it to answer questions, track faces with its animatronic eyes, and respond naturally. Under the hood, it integrates speech recognition, language processing, and text-to-speech to create a seamless experience. RoboNeighbor is also paired with a POV locally hosted dashboard to help navigate and interact with others. This project consists of two main parts, the laptop side and the RoboNeighbor side. Let's begin by explaining start scripts. From the start, I wanted RoboNeighbor to be simple to use for anyone without them having to run a terminal or having to run scripts manually. To solve this, I decided to learn Bash scripting to build start scripts for both the laptop and the RoboNeighbor. Once the laptop is on, it automatically starts the Start Laptop Listener, located in System D, and waits until RoboNeighbor is ready. Once I flip a switch on my RoboNeighbor, it starts my Raspberry Pi, which then starts my Rover start scripts and automatically starts all my software on my RoboNeighbor as seen on the design. After that, it sends a signal to the laptop's Start Laptop Listener to start its own start script and its own software. If the user decides to end the start scripts, all the start scripts are efficiently killed off by their PGID, thus ensuring no orphan or zombie processes. Continuing on, let's talk about our locally hosted Flask server and Jarvis Communication Hub sections. These two sections are the most critical sections in my project. Jarvis Communication Hub and locally hosted Flask server constantly send and receive HTTP JSON payloads back and forth in order to complete RoboNeighbor's requests. Let's start on Jarvis Communication Hub's main logic section, which best encapsulates how these two work together and how each one works individually. Our main logic controls and requests everything. Part of our main logic always listens for the AI activation word known as Jarvis. Once activated, it cleanly shuts off the live two-way audio communication via their process IDs and starts the ROS2 facial detection node. From this, it simply loops over and over again from a listening to a speaking state and so on. In order to speak, it must go through 3 separate requests to the locally hosted Flask server. It must request to the speech-to-text endpoint with the user's voice as the input, then use the resulting text for the large language model, and finally feed that LLM text into the text-to-speech endpoint, which then sends it to RoboNeighbor to respond back to us. Based on the listening or speaking states, facial detection node either sends facial XY coordinates to the IMEC if it's in a listening state, or it sends the idle command to IMEC if it's in a thinking/responding state. If we say terminate Jarvis, the system shuts down the facial detection node, restores live two-way communication, and the passive listener goes back to waiting for the word Jarvis again. Next up, the dashboard. The dashboard connects to RoboNeighbor's ROS2 camera through ROSBridge. That lets my locally hosted web application subscribe to the live video. The front end is built with HTML, CSS, and JavaScript. Finally, onto our controller. The Xbox 360 controller, which is attached to our laptop, is responsible for two things: the motor control of the rover and the manual movement of the eyes. Both commands are sent over UDP to the ESP32's IMEC that controls its servos. I decided that if the facial detection node is currently using the IMEC, the Xbox controller should override and have higher precedence over that node. This means you can control the eyes if it's in Jarvis Assistant mode, if you ever want to. The ESP32's IMEC efficiently manages both UDP senders via a single UDP receiver and a single loop. Hi, I hope you enjoyed my project, RoboNeighbor. This project took me about 4 months and a half to create. All in all, I really enjoyed this project. Sometimes I really wanted to rip my hair out of my head, but all in all, like I said, good times. I want to give my special thanks to the Holland Zeeland Community Foundation area for giving me all the resources I needed to pursue the science and engineering that I love, and kickstarting my career in computer science without having to worry about money or like where to live, all that sort of stuff. So a million thank yous for that. I could not be more grateful. I also want to give my thanks to Yadah, Mitch, and Stacy for directly helping me in my journey as a first-generation student. Their help has meant a lot to me. I really wouldn't have known how to navigate university without them, and without them, I think my GPA would have suffered a lot. So, again, thank you guys for that, and yeah, I hope you enjoyed this project. Also, a quick note on the future of this project. I want to continue it by making it so that you can control the rover from like anywhere, essentially making it like more of an IoT device, Internet of Things device. That way you can communicate with your friends from wherever, and yeah, I think that would be fantastic, and I think that would be the hardest part of this project. So yeah, consider this phase 1 of the project. So yeah, thank you for watching, and if you could leave a thumbs up and share this video, that would be a great help. Thank you.